Hi, my name is Hiram. In this video, I will describe more practically what Aspicere and aspect-oriented architecture are. Let's start with what does Aspicere solve anyway? Aspicere, just like it, solves collaboration problems. Collaboration arises when two or more agents, human or artificial, edit the same documents or pieces of information. For example, buying a pizza online. In this case, the shared document or repository is the pizza order. The agents are the customer, the pizzeria manager, the pizza baker, and the delivery man. Another example, posting a line of text in a microblog, or posting a video or an image in a social networking service. Here, the shared document is the post itself. The agents are the author of the post, an automated censorship service, agents commenting and interacting with the post, and the subscribers. One last example, an insurance case, where the insurance case is, as a matter of fact, the shared document. The agents involved are a policyholder, an insurance case handler, inspectors assessing the damage, and any other person involved in the reparation or analysis of the damaged object. These are just a few examples where collaboration between agents arise. As you can see, it can go from very small documents, like some lines of text, to very complex ones, like an insurance case. There are many ways to solve collaboration problems, and one of them is just versioning systems. Aspicere offers the possibility to exchange data directly between the agents. There is no need to pass through any intermediate infrastructure, like a cloud service. The main data exchange would flow at the edge of the cloud. This is exactly the same workflow used in Git projects. In Git projects, it's not necessary to use GitHub or GitLab. You only want to use those services when you want to work with developers outside your group, or when you want to build continuous integration and delivery pipelines. In the same way, you may want to build applications that only exchange data between agents in the same group. And there may be other situations where you would like to use continuous processing pipelines. We will discuss pipelines in a moment. Another element of this architecture are the aspects. But what are aspects anyway? Let's make an analogy. Imagine working in a pizza factory. We start by receiving pizza orders and then baking pizzas. Now, let's imagine that we receive a huge amount of pizza orders. In that case, we need to hire many pizza bakers. Every pizza baker specializes in preparing a specific type of pizza. If we start to get more orders of a specific type, then we will have to hire more pizza bakers who can prepare that specific type of pizza. We could have supervisors who distribute the workload among the pizza bakers. If a supervisor realizes that a pizza baker is sick, then he would hire a substitute to handle the workload. Now, in order to decrease the damage of an eventual fire, we could locate the pizza bakers in different buildings, minimizing the risk of total loss. In aspect-oriented architecture, a supervisor will become an aspect, and a pizza baker will become a nanoservice. A specific type of pizza will become a specific type of process. For instance, making a commit in a repository, sending an email, or creating a report. A pizza order will be the equivalent to a post-storage commit event dispatched from a repository. If we need to process more tasks of a specific type, then we can create more and more nanoservices to handle that specific type of task. If a nanoservice gets sick, that is to say, if it fails to deliver the result, then the aspect would start another nanoservice and reassign the task to it. Finally, we would locate the nanoservices in different cloud services in order to decrease the impact of a cloud service not working. This is nothing original, of course. What aspects and nanoservices provide is a standard interface to process commit events from end-user repositories. Aspects give a well-defined strategy to cope with many kinds of workloads, from small ones to very big ones. They provide elasticity, resilience, and great performance. Restarting a stateless nanoservice will be much faster than restarting a stateful microservice. But why I call them aspects? Because sending an email or an SMS, creating a report, or saving the result of a computation in a repository are just business aspects of an application. They could be called functions, processes, or tasks as well. Aspect was just more general and abstract, and suited better. How to make queries with this architecture? First, let's take a look at the repositories classification. In aspect-oriented architecture, there are two types of repositories: document repositories and index repositories. Document repositories are nothing else but the repositories that agents use to share the data. In document repositories, we keep track of the document versions. Examples of a document are a pizza order, a post in a microblog, or an insurance case. Index repositories are repositories that keep track of changes in other repositories. You can think of an index repository as an index in a library used to keep track of the locations and contents of the books. If you add a new book in the library, then you update the library index. Index repositories are updated when a document repository or another index repository accepts a commit, more or less in a domino effect fashion. Now, there are two types of queries: infra-repository queries and inter-repository queries. Intra-repository queries are used to find information from a single document repository. These queries are used to process a specific version of a document. For instance, in order to build a report or to send an email, we will need to fetch the value of some of the nodes in a document tree. These queries are done with a language similar to XPath. Inter-repository queries are used to fetch information from many repositories. These kind of queries are, as a matter of fact, nothing else but the index repositories themselves. These index repositories are updated proactively when other repositories change. They could also be built retroactively by scanning the last version in the repositories. For example, if a user of a microblog wants to see all his posts, he can open the index repository of his posts. If a microblog manager needs to see all the posts of all users, he can open the index repository of all users' posts, and so on. How to build continuous processing pipelines. Now that we have a better idea of what repositories and aspects are, we can discuss how to build pipelines. We can build continuous processing pipelines by connecting repositories and aspects in chain. We do not have to be afraid that the elements seem to be connected in a serial fashion. In reality, everything is interconnected in peer-to-peer networks. If anything fails in between, there will be a redundant repository copy or an aspect spinning a new nanoservice to cope with the failures. The pipeline starts when an agent makes a data commit in a document repository. If the repository accepts the data commit, it will dispatch events that other aspects will handle. Those aspects in their turn will process the commit events and maybe write in other index repositories, and the story repeats again. If those repositories accept the data commits, they will dispatch events that other aspects will handle, and so on and so forth. The pipeline could finish by updating some kind of macro index repositories, probably used as business intelligence data sources. They could also finish by sending emails, making reports, or starting other processes. Then again, this is nothing original. The advantage is a decreased time and cost by having well-defined and standardized functions, protocols, fallbacks, backup strategies, etc. Developers would only need to focus in defining the document schemas, adding the pico-services and nanoservices business functions, and configuring the interconnections of the pipelines. They would not have to worry about managing the concurrency, low latency, fault tolerance, and redundancy matters. All that will be managed by the platform with the help of some configuration parameters. How to visualize all these elements? The nomenclature in the commit events has been carefully selected in order to be related to real-life objects. A perimeter is equivalent to an environment. Cluster and cabinet are just logical data containers. This would allow to build 3D interfaces to navigate the repositories more intuitively. It wouldn't be necessary to make complex queries with table joins or conditions. Instead, it would be possible to navigate the document versions and trees directly, just like with Git tools. Support personnel will navigate to the necessary perimeter, look for the right cluster, and open the cabinet they need. Then they would open the repository, look for the affected commit, and navigate to the tree, finding all history and telemetry necessary to spot a failure. The main objective of intuitive interfaces is to make it possible for first or second line support to find the problem in the application quickly. It will also be useful when developers need to debug the applications. There are still 100 things to clarify due to the complexity of this architecture. The reason, of course, is because this architecture is intended to solve complex problems. And like they say, for every complex problem, there is an answer that is clear, simple, and wrong. I hope this video helped to grasp the essence of Aspicere repositories and Aspicere aspects. Thanks for watching.